In this demo, we'll learn about a language feature introduced in C#6 called interpolated strings. We will see how these provide a convenient syntax to define formatted strings. At the end of the module, we will learn about interpolated string handlers, a feature introduced in C#10 to improve performance when using string interpolation. We've used several approaches for concatenating and joining strings so far in this module. In most situations, we can prefer a feature introduced with C#6 called String Interpolation. This feature provides a terser, more readable, and often more convenient way to define and format strings, requiring a combination of literal and runtime values. We use a $character before the opening quotation mark to define an interpolated string. An interpolated string may then contain interpolation expressions. When the string is resolved to a result string, these expressions are replaced by their result. The interpolation expressions are included by wrapping them in curly braces. In this example, an interpolated string is defined, which includes some literal characters and a single interpolation expression. The expression here calls datetime.utcNow. At runtime, this string resolves to a result string containing the formatted date. We can also include format specifiers to control the formatting of the value. In this updated example, we'll specify a date format specifier after a colon. The result string now includes the date with the specified format applied. We'll return to the sales data summary report writer to refactor it to use interpolated strings. We'll start a new interpolated string for the initial row by using the $character. We can include our literal characters at the start of the string. We then want to include the user's details, so we'll begin an interpolated expression with braces. The expression will simply access the forename from the session context. After a space, we'll add a second expression to include the surname. Finally, we can add the new line with another expression. The advantage of interpolated strings is that this is much more readable when compared to using composite formatting. We no longer need to provide the objects as arguments at the end of the method and then calculate their index position. With format strings, it's easy to make mistakes and insert the values into the incorrect locations. With this interpolated string, it's much easier to interpret how it will appear because the expressions appear at their correct locations. Let's replace our other string manipulation code to prefer interpolated strings. I'll comment out these existing lines of code. We'll concatenate a date using an interpolated string. After some literal text for the date label, we can include an expression to access the UTC sales date time from the item. We'll include the long date format specifier in this expression. We can add a second interpolation expression to finish with a new line. I'll copy this and paste it 2 more times underneath. We'll update the labels for each of these to display the product name and product SKU labels. Then we must update our expression to access the expected properties on the item. What about formatting and culture though, I hear you ask? Great question. By default, the interpolated string will use the application's current culture when formatting types to strings. It's possible to control this, but the mechanism is a little less obvious. I'll copy our interpolated string as we'll need to do something special with it in a moment. To format in a culturally aware manner, we can implicitly cast as a formattable string. A formattable string represents a composite format string along with its arguments. With this done, we can use the formattable string to write out a string formatted using the configured application culture. We call toString on the formattable string instance and pass in the culture info as the iFormatProvider argument. This can be useful in some circumstances, but it introduces an extra line of code and, in my opinion, is less clear. We could actually rewrite this another way. Let's return to the interpolated string that we had before. To support cultural aware formatting, we can just call the toString method on the date as part of the expression. We can now provide the format specifier and the culture info. This works, but may become less efficient, particularly inside a loop. String interpolation is a language feature. Under the hood, the compiler is free to rewrite interpolated strings by generating the code that it deems most suitable. Multiple mechanisms may be used depending on the situation. The compiled code may include the use of string concat or string format. Therefore, despite the convenience of interpolated strings, the same considerations regarding string allocations still apply. C#10 though introduces a new mechanism called interpolated string handlers, which the compiler may choose to apply for interpolated strings. An interpolated string handler is a value type that can efficiently process the placeholder expressions of interpolated strings. It acts as a builder for the final string, internally employing techniques that reduce allocations as much as possible. We're using C#10 in our application, and if we were to decompile the code of this produce report string method, we would see this interpolated string compiled to something closer to this code. It creates an instance of the default interpolated string handler, which is a stack-only value type causing no heap allocations. The constructor accepts the length of literal characters and the number of formatted elements used to create a suitable internal buffer. The implementation uses an array pool to reduce allocations. Data can be appended to the builder by providing either literal strings or expressions to be formatted. Once the elements are all appended, toString and clear is called, which produces the final string and clears the builder, releasing the buffer back to the pool. This is more verbose code, but much more efficient. Fortunately, we don't need to write this code ourselves, and we can rely on the compiler to convert our interpolated string into the most appropriate code. It's possible to define bespoke interpolated string handlers for advanced scenarios. For example, you could imagine a case for a string handler that can build valid URLs and apply proper URL escaping. Microsoft's example in their documentation is creating an interpolated string handler for writing log messages. Such a handler could be aware of the configured log level for the application and avoid allocating strings for logging that are not required based on their log level. Crafting custom interpolated string handlers is a topic on the advanced end of the spectrum and beyond the scope of this course. Interpolated strings in C#10 will generally cause the fewest allocations when compared to the other techniques that we've covered in this module. As a general rule, prefer using them over operators, string concat, and string format. That concludes our look at ways to combine and format strings. Join me in the next module when we look at ways to perform more efficient string manipulation by using string builders.